Welcome to this section of the playlist, and for this video we will talk about table reflection. The simplest table reflection, multi-table reflection, how to reflect existing tables and convert them into Python classes, create and manage sections for interacting with database, create new database objects and query existing ones using the reflected models. Now, what is database reflection? Database reflection in SQLALCHEMY allows us to work with an already existing database where you have no models predefined. With database reflection, we can retrieve the metadata and schema of a database and be able to interact with it. With database reflection, we can be able to load the structure of the database tables and schemas we are reflecting into Python representation as SQLAlchemy tables and objects and metadata instance. Also, note that reflection only retrieves the structures and not the actual data. To get the data, we use the reflected tables to get the data. Now, let's look at how we can do this with examples. In the previous videos, we've always been using DB engine, but for this one, we are going to be talking about single table reflection, and then we talk about multi-table reflection, and then we talk about how to reflect table into Python classes, that is the models. So I've created these three different files and we are going to treat them as their own file, no importation from any other module that I have locally here. So here I'm importing get VMV from OS for retrieving environmental variables, and I'm using load.env to enable me to retrieve them. I'm importing create engine metadata and the table from SQLAlchemy because we are going to be using them for the single table reflection. And below here we see where I'm creating my connection string and we are passing it to the create engine, which is the engine that we are going to be using to interact with the database. So when it comes to single table reflection, when we reflect a single table, only that table is always loaded as an object. But if the table has a relationship with another table or more than one relationship, all related tables are loaded by default as well. So we are going to start by creating an instance of this metadata that we imported there, because you see I'll call it reflect metadata. If databases were people, metadata would be there. So for us to reflect a single table, let's say I want to reflect the employees table, and what we're going to do is to use this table object that we imported here, and inside this table object, just the way we created the tables before, we pass in the table name employees followed by the metadata instance, and then we pass in this auto load with option. Auto should be auto load with, and then we pass in this MySQL engine. This auto load attribute will load the table attribute when we first run the script. Subsequently, new calls to this table object won't utilize this auto load with argument. So what we have done here is reflect this single table. As it stands right now, we can be able to retrieve and print out some of the features of this table. For instance, let's get the column names. I'll say columns is equal to, I'll use a list comprehension. I'll say for C in employees dot columns, and I'll pass it in here, and then I'm going to use print then I'll pass in the columns. Just to differentiate this, I'm going to so again let's print out the constraints of the table. So this, okay, let's run this. I'm going to cd into core, and I'm going to cd into this reflection. And I'm going to run the single table reflection. And we can see where we have the columns. We have this column which is ID, and we have another column name, we have another column email, we have another, which other column do we have? We have another column position, and we have another column manager. And here these are the constraints for foreign key, where we set on delete to null and link name, and for the next column which is ID. So also we can be able to use this table now for queries. Let's say, let me create a statement, and I'll say employees dot select, and I'm going to pass this statement to, okay, let's create a connection. I'm going to say my SQL engine dot connect. I'm not using a context manager, I just want to print this out. I'm going to say result is equal to con dot execute, and then we pass in the statement, and then we come down here and we are going to print the results. But first, let's convert it to a list. Let me comment out these ones, and let's run this again. So we see that we got the data in the table. So now let's look at how to reflect more than one table. I'm going to close this one, and so we are going to create a metadata just like before. I'll call this reflect metadata, and we create an instance of this metadata that we imported just like we did just now. And we are going to call the reflect method on this metadata instance, and then bind engine to the reflect method. Say reflect metadata dot, we call the reflect method, and then we say bind, and then we pass in the MySQL engine. So this part here will populate our metadata instance with the table objects. So if you're using the database that supports multi-schema, you can specify the schema name to reflect by passing an argument here called schema, and it's supposed to be a string. But I don't think my SQL supports it. This is usually supported by Postgre. So this reflect function takes another argument, which is views. That is, if you have views that you want to reflect, you can pass this flag and set it as true. This would equally reflect all views. If you do not set this flag, the default value is false, the views will not be reflected. Also, assuming that we want to reflect only the users table and the accounts table, we can pass in another parameter, which is only. This only checks in a list, and inside this list is where you specify the table you wish to reflect, like users and accounts. But I'm going to leave this here, and I'm going to comment it out for reference. I'm going to copy it, comment it out, paste it again, but I'm going to remove all of this except the engine. So once the database is reflected, we can retrieve the reflected tables by saying tables equal to reflect metadata dot tables. So this is going to retrieve all the tables that we just reflected. So, and from the tables, we can access the table of the choice of our choice individually. We can say users is equal to tables. This table object here is dictionary like. So we can pass in users and we can pass in accounts, and also we can pass in addresses. So if you try to access a non-existing table, a key error would be thrown. So reflected table objects provide information about the table schema itself. So let's print out some of the table schema for the users table. So we are printing out all the column names, their type, and nullable. I'm going to clear. I'm going to say run the multi-table reflection, and we see that we have the first column, which is ID and is an integer, and email, age, and so on. So beyond the basic table columns details that reflection can provide, reflection can provide more schema information like primary key constraints and so on. So to get primary key constraints, we can say let's get one for user pk, and we say users dot primary key. Also, we can even get the foreign keys and so on by appending all of it to users. So also the reflected tables can be used to perform queries. I'll just paste this thing. Now pasting statement 2, and then we can print them out. I'm going to run this, and we see that we've retrieved the users from the table. Also, we can be able to delete rows in the database with the metadata reflection, but I must warn you, you have to be careful with this one. So for us to be able to delete, I'm going to try to delete a single thing, not clear everything in the table. So we say MySQL engine dot, okay, let's use begin dot begin as con, and I'm going to say for table, and I'm going to use this reversed, where is it? And I'm going to pass in the reflect metadata dot sorted tables, and then here we can say con dot the connection dot execute, and then we say table dot delete. If we should run this code, this would delete every row in all of the tables, but what I'm going to do is to, let's just do for one thing and delete. I will say I'm passing a where clause where table dot colon dot id is equal to, let's see if we can remove the fourth one, is 4, and I'm going to take this and copy it down so we can print out again, and then I'll run this. So we see that when we printed it out, Clio was there, but after the deletion, Clio was no longer there. So Let's look at how we can reflect tables back to Python class, Python models. I'm going to close this one. So creating models from reflected tables can be done by using the SQLALCHEMY ORM to map here, this line, to map database tables to Python classes, which will allow us to interact with database tables as if they were regular Python objects. So I've made the necessary imports. So we are going to see how we are going to be using each and every one of them. So the first thing I'm going to do is we are going to first create a section, because when it comes to model, we should be working with sections. So I'm going to create a section. I'm not going to initialize it. I'm going to just create it, section maker. And then we are going to pass in bind, which is my SQL engine. And I'm going to also pass in some so I do not want auto flush for each section. I want to be able to flush it myself, and I don't want the section to expire on commit. I want to expire it myself. So as usual, we always need the metadata. So I'm going to create another one. I'll call it reflect metadata, and we are going to use this metadata object that we imported here to create an instance of the metadata. And then we are going to call the reflect method on the metadata dot reflect, and then we bind the engine to it. So if the database you're using supports more than one schema, just like I've said before, you can use all those options, but mine is not, obviously. So the next thing we are going to do is we are going to create a base using this declarative base. Usually, I think declarative base before 2.0, declarative base was gotten from SQL alchemy.est.declarative, where you say import declarative base, and then you would create something like this, base equal to declarative base. So this was done before 2.0, but I'm using 2.0. That's why I'm going to be using this declarative base. And the way you use this is you also create a class and call it base or whatever you wish, and then you pass in the declarative base inside of it. And then as a class attribute, you're going to you say metadata, and you set it as this reflected metadata. That way, this base now is going to hold all the metadata that we reflected from this table, from the database. So the next thing we are going to do is to map all the reflected tables to Python classes by saying base. We are going to pass this base to this auto map base that we got up here. Say auto map base, and we pass in this base to it. This base we created there. So it's going to the automap base function is going to create a new base class for ORM models. Push this down, and the next thing we do is we are going to say base dot prepare. So this prepare method will read the reflected tables and then generate the corresponding Python class for each table. This is the point where the classes are generated as models. So the next thing we're going to do is to access the reflected tables as models from this base. So we are going to start with the user, and we say user equal to base dot classes dot users, followed by account, base dot classes dot accounts, and then followed by address base dot classes dot addresses. Now that we've gotten the models from these base dot classes, all of these models can now be used just like every other SQL Alchemy ORM models. And no worries, sometime in the future, we are going to cover SQL Alchemy ORM, and I just needed to cover the ORM, the SQL Alchemy core, before we can move to ORM. So we can now use this to interact with the database. And I'm going to create a section using a function generator, and I'm going to be using the context manager. This context manager that I imported from context lib. If you're not familiar with context manager, I made a video for it. I'm going to leave it in the description section, and it should also be popping up on the top right of your screen. So I'm going to use the context manager decorator to create a generator function. I'm going to call it section generator. Then I'm going to say try section is equal to, and then we are going, this is the point we are going to create a section, because we want a different section for anytime we use it. So we are going to say yield section, and then we say accept, and then finally we have to close the connection. We say section dot close. So let's try to create a new user. I'm going to say with section generator as section, and then we are going to say new user is equal to, so we are going to use this user the way we use classes, and we pass in name, and then we say section dot add, and then we pass in new user, and then we say section dot commit, and we have to print this out. So I'm going to paste it in. So we are using the section generator again to print this out. So we are going to print in out the ID, the name, email, and age. I'm going to clear. I'm going to run flat to models. Should be Python 3. So we see that we've gotten the values. So the next one, we are going to look at triggers and procedures. If you're yet to subscribe, please subscribe to my channel and leave a like on the video so that it can be able to reach others. Thank you for watching.